Hi everyone, welcome back. Hope you are doing good. This is Mahesh. In this video, we will learn about insertion sort. So what is this insertion sort? So basically, it is like playing cards. So we have deck of cards which are placed on the table. So what we do normally while playing cards, we pick a card and we hold it in our left hand, and then we pick the next card. Then we will search for its position and then we insert it. Then again we pick the next card and we insert it into its correct position. So that is how we keep on adding the cards. So that is the principal logic of this particular insertion sort. So let us look into that using this particular example. So we have 21, 15, 7, 8, 3, 5. So what I will do, so let us assume they are the cards which are placed on the table, and first I will take this card and I will hold it on my left hand. So there is nothing apart from this card, so let it be. Now let us pick the next card, which is 15. So I will take 15. Now should I place it here? No, that is not the case. Since 21 is bigger than 15, what I will do, I will shift 21 towards right and then I'll place 15. Okay. Next what I will do, next I pick the next card, so which is 7. So should I place this here? No, because 21 is greater than 7. So I'll shift 21 to right. Okay, but is it the correct place? No, because 15 is still greater than 7. So I will place 15 here. Then since there are no elements, I will place my 7 here. I'll pick 8 again. So 21 is greater than 8. So I'll shift 21. Then 15 is still greater than 8, so I'll shift 15. Then 7 is smaller than 8, so I'll stop and I will simply place my 8 onto the position after this particular 7. So this is the correct position for 7. Now I will pick 3, so 21 is greater, so I'll shift 21. Then 15 is still greater than 3, so I'll shift 15. 8 is greater than 3, so I'll shift 8. 7 is still greater, so I'll shift 7. There is nothing after 7, so what I will do, I will simply place my 3 here. Okay, so next last element 5. So 21 is still greater, so I'll shift 21. 15 is still greater, so I'll shift 15. 8 is still greater, so I'll shift 8. 7 is still greater than 5, so what I will do, I will shift 7. 3 is less than 5, so here I will stop, and the next position what I will do, I will simply place my 5 here. So this is how we get the sorted elements at the end of all the iteration. So let us look this using some proper variables. Okay, so this is my array. So what I will do, I will start with first element. So these are the indexes. Basically I'll start with first index, because this, if we consider this is already in its sorted position. So I will start from first index. So I will point my one pointer, which is I, here. Okay, then if I have to consider this element as my card, so this will become a key element for me. So I will take a variable key and I'll assign whatever is there at ith index to this particular key. Okay. Next, what I require one more pointer which traverses towards left and search for this element's proper position. So what I will do, I will take j, which is 1 less than I. So this is my j here. Okay, so for easy understanding, what I will do, I will place I, this is my j. Okay, now I will start from here. So this is my 15, this is my I, and this is my j. So my I is 1. So what my j does, j checks whether this element is less than my key element. Key element is basically this element which is at ith position. So since this is greater, what I will do, I will simply place my element at j with j plus 1th element. So it means this element gets replaced with 21. Okay, next I will decrement. So now j is 0. Okay, I will, once this placement happens, this shift happens, my j gets decremented by 1. So now it is equal to -1. -1 means it is outside my array. So I will stop here. There are two conditions we need to consider. Either j should exhaust my array, or we should get an element which is less than my key. So at that place we have to stop, and then what we need to do, we need to increment j by 1, and then we need to place our key at this particular place. This is at the end of first iteration. So if you observe, this much is sorted, this is still unsorted, this is still unsorted. Okay, now what I will do, I will increment I. So now my I points here. I'll remove these things. My I points here. Now I'll reset my j. My j will point here. Okay, so I will be 2, j starts from 1. Okay, now I will again repeat the process. My key gets updated with the value at I, so that is 7. Okay, now I will check this value. So 21, it is greater than 7. So I will simply replace j plus 1th element with element at j. Now I will decrement. Decrement means now it goes to 0. So it comes here, j points here now. Now again I will check with key value, which is 7. So 15 is still greater than 7. So what I will do, I will simply shift 15 to right side. So one place ahead. Now after this, my j will get decremented by 1. So now it moves out of the array. So I will stop here, and then what I will do, I will simply increment and I place my key here. Okay, now let us repeat the same process. So again, if you see here, till here the elements are sorted, these are unsorted elements. So now I will remove this. Now I will increment my I here. My key gets updated with 8. So again I will start the process. So I is 3 and this is j. J starts from 2. Okay, so now 21 is greater than 8. So I will replace j plus 1th element with element at j. Next I will decrement. So it comes to 1 here. This is j. So 15 is still greater than 8. So I will replace this with 15. So it gets decreased to 0. So j is at 0 now. Now if you see, 7 is less than 8. So this is a very important thing what we need to understand here. Once this element is lesser than 8, I will stop. I don't do any further things. Then what I will do, I increment this by j by 1 and I will simply place my key here. So if I do this, then 8 will be at its correct position. Okay, so now this is done. Next I will move my I. So till here it is sorted. Now I will move my I here. So I becomes 4. J starts from 3. Okay, it is 21, which is, and I should update my key before that. So 21 is greater than 3. So I'll replace j plus 1th element with 21 and I'll decrease my j. So j points here. Okay, 15 is still greater than 3. So I will replace this with 15. This gets updated with 1 and now 8 is still greater than 3. So this value gets replaced with 8. This comes to 0. This comes to 0. Okay, 7 is still greater than 3, so this gets replaced. Now my j goes to -1. So once it goes to -1 outside, I'll stop. Then what I will do, I'll increment this and I'll place my key here. Okay. Now let us repeat the same process for the last element, which is 5. So index is also 5 here. So my j points to 4. So this is my j and this is my I. So 21, and let's update key with element at I, which is 5. So 21 is greater than 5. So I'll replace jth one element with jth element. I'll decrement j. J will be 3 now. Here 15 is still greater than 5. So this gets replaced with 15, and I will have to decrease my j. So j will point to 2 now. 8 is still greater. So then j gets updated. It comes here, and still my 7 is greater than 5. So the next element gets replaced with 7, and j gets decremented by 1. Now j points to 0, but if we see this element is less than 5, so I'll stop. And then what I will do, I'll simply increment this by 1, and I'll replace this value with my key. So if you see at the end of this ith, the iteration of the I, so all the elements get sorted. So this is basically the logic for this particular insertion sort. Basically we try to search for its correct position, and then we place that element at that correct position. Okay, now let's look into the pseudocode. Okay, let's retain this table. So here what is happening, my I is getting incremented, or it is getting iterated from 1 to n-1. Okay, so this is the first step. Then second step, what we did, we assigned the element at ith index to a variable called key, and then we took this j one place before I, and then we started decrementing j towards left until it reaches until it goes out of the array, or until we get an element lesser than our key. So let us write insertion sort method. So this method takes input a, which is array of numbers. Okay, then n is basically our length of the array. Okay, then we have for loop which iterates from 1 to n-1. It iterates from 1 to n-1. Then what we did, we assigned the element at ith index to a variable called key, and then j is equal to I minus 1. Okay, now let us take a while loop. So because we want to replace element unless we get a smaller element, or until the j pointer exhausts the array. So while j greater than or equal to 0, and our key is instead, let us take something, a of j is greater than key. What we will do, we will simply replace a of j plus 1 with a of j. Okay, after this what we did, we decremented j. Then once this is done, we simply increment j by 1, and we will assign that with key, because this stops whenever we get smaller element or whenever j gets exhausted. And at the end we will simply return a, and we will close the entire method. So this way, I mean, we will get the sorted values at the end of this particular for loop. Okay, now let us look into the time complexity for this procedure. So now if you look into this pseudocode, on a naked eye, what we see a for loop, then we see a while loop. So basically there are two loops, that too they are nested, so we can say it is of order n square. Let us see that. So this is value I, and what we did, we started from 1 and we looked backwards, and what we did, we compared something and then we did some replacement, or we did some insertion. So basically we need compare, then some insertion. Okay, so when I was 1, we did one comparison and max one insertion, so 1 plus 1. So when I was 2, we did two comparisons and two insertions in worst case, and when I was 3, we did 3 compares and 3 insertions. We continued this till n minus 1, so it is n minus 1 compare and n minus 1 insertions. Okay, if we sum it up, it comes something like this: 2 into n minus 1. Okay, so let us take 2 common. This becomes 1 plus 2 plus 3 plus 4 and so on till n minus 1. So this is basically n minus 1 natural numbers. Okay, sum of n minus 1 natural numbers, which we will consider it as n for simplicity. So this comes around n into n minus 1 divided by 2 into 2. So 2 get cancelled, it becomes n square minus n. So since we consider highest degree term here, this becomes of order n square. So the time complexity for this insertion sort is of order n square. This is the worst case time complexity, but let us assume the array is already sorted, something like this: 1, 2, 3, 4 and 5. Okay, so here we will start here. We will compare with 2, we will compare it with 1, but it is both are already in their correct position, so we don't do any modification. Then we will go with 3. Again, we will compare this with its previous element. It is already in their correct positions, so only we do n number of comparisons. No other options if the array is already sorted. So that becomes our best case time complexity. So for best case, our time complexity will be of order n. This is for our best case, but for worst case and average cases, it is of order n square only. Okay, now we will look into space complexity. Okay, so what we did, we took this n, we took key, we took j, but nothing apart from this. So basically what I'm trying to say, we did whatever modification in place, so within this array itself. So that's why it is a in place sorting algorithm. That's why its complexity, space complexity, is of order 1. Okay, so this is about the pseudocode. Now let's look into its program in action. Let's create a class which is insertion sort dot java. Then this is the class. Let us create a static void main method and keep it. Let us create a public static method which returns us array of int values. It's a sort method and it accepts input, which is array of int, and that is basically our a. And now let us create int variable n, which holds the length of array. Now use for loop int I equal to 1, I less than n, I plus plus. Then let us take a int variable which is key, which holds the element at ith index. Now let us take one more int variable j, which is equal to I minus 1. Now let us create a while loop while j greater than or equal to 0, and add a of j greater than our key. What we will do, we will simply replace j plus 1. We will place a of j plus 1 with the element at jth index. Then once this is done, we will simply decrement the value of j. Once the end of this while loop, what we will do, we will simply increment our j by 1 value, and then now we will simply assign our key to the element at j plus 1th index. So once everything is done, after the end of our for loop, let us return our sorted array, which is a. Now in the main method, let us try to create array which is int a, which is 21, 15, 7, 8, 3 and 5. Now what we will do, we will call sort method and pass a to it, and reassign it to variable a. That way, we will get the sorted array back to the same variable a. Now let us use a for loop to print our sorted numbers. So for int num colon a, then we will use system dot out dot print, not println, let's use print, and we will try to print number. And after this, we will duplicate the line and we will simply put a space after each number. So once this is done, let us try to run this and see the output. So if we see, we get the sorted array here: 3, 5, 7, 8, 15 and 20. That's it for this video. Thanks for watching the video.